Understanding dynamic programming.
Dynamic programming is a technique for solving complex problems by breaking them into simpler subproblems. It is especially useful when the problem has overlapping subproblems and optimal substructure. By storing previous results, dynamic programming avoids repeated work, making solutions faster and more efficient. Many common coding problems can be solved with dynamic programming using distinctive patterns.
Pattern 1. Memoization. Top-down.
Memoization is a top-down approach where you solve a problem recursively and store results of subproblems. If you need the same answer again, you use the stored value instead of recalculating. For example, in the Fibonacci sequence, memoizing saves time by avoiding recomputation of previously solved values. This pattern is useful for problems where recursion revisits the same input multiple times.
Pattern 2. Tabulation. Bottom up.
The tabulation works from the bottom up, solving smaller subproblems first and using their answers to build up solutions to larger problems. Results are stored in a table, usually an array. For instance, in the coin change problem, you build a table where each entry represents the minimum coins needed for each amount. This pattern eliminates recursion and is efficient for many problems.
Pattern 3. Subset and knapsack problems.
Subset and knapsack patterns involve decisions at each step, such as including or excluding an item. The classic 0-1 knapsack problem is solved by building a table that tracks the maximum value you can achieve for different item combinations and weights. This pattern is common for problems related to combinations, partitioning, and optimal selection among constraints.
Pattern 4. Longest sequence problems.
Problems like finding the longest increasing subsequence or the longest common subsequence use dynamic programming by comparing subarrays or substrings. Solutions typically use a grid to record the lengths of matches and build up to the final answer. These patterns are widely used in string analysis, bioinformatics, and sequence comparison tasks.
Key takeaways in practice.
Recognizing dynamic programming patterns helps you break down complex coding problems into manageable steps. Start by identifying overlapping subproblems and deciding whether memoization or tabulation fits best. Practice with classic examples such as Fibonacci, coin change, knapsack, and sequence problems to reinforce these techniques and enhance your problem-solving skills.